Hi everyone, I am Rosajane Tagalog from BSA 3K CSS reporting Calamondin. Calamondin or the citrus mitis comes from a family Rutaceae is an acid citrus fruit originating in China. It is a result of natural crossing between mandarin and kumquat. It is now widely grown in India and all over South and Southeast Asian countries, especially Indonesia and the Philippines. It was introduced to US as an acid orange about 1900s. It became the most important citrus juice source in the Philippine island. Calamondin fruit is well known for its acid juice, which is used as a flavoring for dishes on seafood and meat. It is also processed into drinks and various products. The stem of Calamondin is an erect, slender, quite cylindrical, densely branched, beginning close to the ground. It has slightly thorn and develops an extraordinary deep taproot. And when it matures, the height ranges from 12 feet to 14 feet, with a spread of 8 to 10 feet. The leaf has an evergreen color that is single leaflet with an alternate aromatic broad oval, dark green, glossy on the upper surface, yellowish green beneath, which ranges 1.5 to 3 inches long. It has faintly toothed and at the apex with a short, narrowly winged petiole. The flower of calamondin has a rich, sweet fragrance, which has 5 elliptic oblong with pure white petals that are about 1 inch or 2.5 centimeter wide. It has borne singularly or in twos or threes terminally or in the leaf axis near the branch tips. The fruit are round or oblate and to 1 3/4 inches or 4.5 centimeters wide, with a very aromatic orange-red peel in color, glossy, and dotted with numerous small oil glands, which is tender, thin, easily removed, sweet, and edible. While the pulp has 6 to 10 segments, which has an orange in color, very juicy yet contains high acid and either seedless or with 1 to 5 small obovoid seed that is green in color. For macronutrients which are essential for plant growth, which includes elements nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. Nitrogen has the greatest effect on citrus growth and appearance. It is the element used most to produce leaves, flowers, and fruits. Phosphorus, particularly concentrated in younger tissue, helps the citrus store and use energy and take in nutrients. It also is essential for cell growth and cell division. Potassium and calcium are used in relatively great amounts by citrus to produce leaves, flowers, and fruits, while magnesium is crucial in photosynthesis and stimulates phosphorus uptake. Sulfur is a part of many proteins and improves root growth, vigor, and hardiness. And for the micronutrients required by citrus are smaller quantities. Sometimes it was referred to as trace or minor elements, which includes iron, zinc, boron, copper, manganese, molybdenum, nickel, and chlorine. Iron is important for the production of chlorophyll, while zinc plays a role in carbon metabolism. Carbon is important for sugar translocation, flowering, and fruit processes. Manganese is essential for making nitrates usable, and copper plays a role in several systems and processes. Molybdenum assists in vitamin and starch formation. Climate and soil. Calamondin is adapted to warm climates, but it can also grow in cool, frost-free areas. It can grow in any soil type but prefers a well-drained, sandy or loam soil rich in organic matter, which has a pH of 5.5 to 7.0. in locations with annual rainfall of 1500 to 2000 millimeter. It has moderate tolerance to drought and shade but cannot tolerate excessive moisture and strong winds. And for the fertilization of Calamondin, nitrogenous fertilizers like urea are applied at the rate of 50 to 100 grams per tree starting from 1 month after planting and every other 6 months. This rate is increased to 200 to 300 grams per tree in the second year. When the tree starts bearing fruits commercially, 350 to 400 grams of complete fertilizer is applied. The rate increased correspondingly as the tree becomes bigger. The fertilizers can be distributed into 6 to 8 holes around the tree and timed with the onset and end of the rainy season or just before the start of flowering. The incorporation of organic fertilizers in the fertilization plan will also benefit the plant by providing micronutrients. With potted calamundin, it is better to apply slow-release fertilizers. Likewise, the use of 1 to 2% solution of a mixture of nitrogen and complete fertilizer may be an alternative. Health benefits of calamundin. One of the benefits of calamundin is in weight loss. It removes toxins that contributes fat storage in the body. The juice improves passive fat burning and also detoxifies the body. It also controls cholesterol level. The juice helps in reducing cholesterol level as it can also lower the risk of atherosclerosis, heart attack, and stroke. Calamundin also improves respiratory health. It is very common, especially Filipino, that we use calamundin as an aid for cough, as calamundin cut through phlegm and mucus, where some of the infectious often live and propagate. It is also has a strong citric acid level. So, calamundin also lowers acidity. It can also lowers levels of inflammation, lower risk of developing ulcer, and protect from acid reflux diseases. It also boosts immunity. Calamundin encourage the production of white blood cells and encounter the negative effect of free radicals. It also promotes collagen production. The juice supplies a burst of ascorbic acid that increase the body's ability to grow, as well as repair the damage from injury, illness, and surgery. Nutrient level at varying growth. Mature fruit can produce year-round but abundant from November to June. One calamundin has about 12 calories with a very small trace of fat. It contains approximately 1.2 grams of fiber, 37 milligrams of potassium, 7.3 milligrams of vitamin C, 57.4 milligrams of vitamin A, 8.4 milligrams of calcium, 15.5 grams of water, and 3.1 grams of carbohydrates. Nutrient deficiency. Nitrogen deficiency first appears as a paling of foliage, while zinc deficiency is if chlorosis develops between leaf veins and shoots form with nodes spaced closely together and smaller leaves. Potassium deficiency appears as yellowish leaves with edges bent downward. Magnesium deficiency appears as leaf yellowing that begins at the leaf tip and margins. It is sometimes leaving a green patch at the base of the leaf, while iron causes a net vein pattern with intervenal yellowing. that primarily appears in young leaves during the fall growth flush, while manganese deficiency forces a slight leaf yellowing.